Okay, here we go. Now we're going to look at Shop Job 2301, and we've taken 2201 and we've added jog functionality into that particular job. And we've done that through three different items here. We have a two-position selector switch, which we're calling mode, and that is going to select whether we are in a run situation or a jog situation. And down here we've got a blue light that when we select jog, the blue light's going to come on and let the operator know if they press the start button, they're going to be jogging the motor instead of running the motor. And in this job, we have also incorporated a run timer. It's going to be a retentive timer, and we're going to need a way to reset that. So I have a reset button in here as well. So that is this right here. Okay, so those are our three additions to 2201. Let's go over to our 2201. And I've already just taken that and renamed it and changed the description up here, but haven't changed any of the code yet. So what we want to do in 2301 is for the jog function, we want to be able to disable this right here. Okay, so to do that, we're actually going to add an instruction down here, and we'll go back and we'll look at our, I'm saying here, A should be run and B should be jog. And so here, if we look at our two position selector switch, A equals close and B equals open. So in looking at that, we want to be closed in order to have our holding circuit. So I want to use an examine of closed, and this is going to be my I:0.0/3, and that is directly from this sheet over here. You see right here, this 3 is my two position selector switch. Okay, and so this is going to be mode A equals run and B equals jog. Okay, so if that switch is closed or in the A position, I'm going to be in the run function, and if I am open, this will evaluate to false and I'll be in the jog function. It'll be disabling that. Okay, and we want to add that blue light in here. So the blue light we want to come when we have selected jog. Well, we know B is open and B also equals jog, so we want to do an examine if open here on this address. Copy that down here. So if that is open, that switch is open, we want to turn the blue light on, which is that output 2, and we can verify that over here. Come down to our blue light implementation right here, and you see it's output 0.0/2. Okay, so this is going to be motor jog selected. Okay, that's what that's indicating, and we'll call this JOGGING. Okay. Okay, so that's going to be our blue light implementation. Now all we need to do is we need to add in our timer, and it's going to be a retentive timer to time the motor when it's running, so we can keep track of how many, in this case, seconds for the motor running. So we want an examine of closed, and we're going to test those status input for the motor to see if it's running. If those contacts are closed, that means the motor's running. I'm going to come up here to the counter timer tab, and we've been using TON so far, but we're going to come over here and use RTO, retentive timer on, and I'm going to pick a different register than before, so we're not, if we combine jobs, we're not going to be overlapping there, and this is going to be the running timer, and RUNTMR. Okay, So that's going to give me a running timer. Of course, we want to time for seconds. Now, this timer will only time for as long as the preset value. And if the preset value is 0, it means it'll never time. So what I want to do, because I'm not really worried about a done bit being set here, I just want to keep track of seconds. I want to set the highest value that I can in this preset value. So when we start studying the binary to decimal conversion, you'll see where this number comes from. But the highest number I can put in here is 32,767. So that is going to max out my timer, and it'll time for at least that long, which is approximately 9 hours. Motors run for longer than 9 hours, but we're just working our way into an implementation here, and we'll come up with a better way to calculate run hours in a future shop job. Okay, and then there's only one other thing that we need to do, and that is to add reset functionality in here. So I want to add another rung, and remember it's the yellow push button. So I:0.0/6. In this case, it's going to be a reset timer. We're going to call this reset. Okay. And here is a special instruction under my timer counter, and it's an output instruction called RES, reset. And all you have to do is type in the register that you want to reset, and we assign this one to T41. So we're going to reset T41. Okay, so whenever we push on that yellow push button, we're going to reset that timer. Okay, so that's all the code that we should need. So we're going to go ahead and download this, and then we're going to examine how it functions. Okay, so right over here, my selector switch is in the B position already. Down is B, and because of that, we'll go ahead and look at the light implementation here. Because it is selected, I have my blue light. I'm going to come over and deselect that. Okay, so since I closed that switch, this is examining for open. It became false and turned my light out. So now I'm going to actually be starting my motor. I'm going to come up here so we can observe here. And I am now in the run mode. So I have at least my first instruction is testing to true, because we want to enable that holding rung. And now all we have to do is invoke the motor. And if the motor starts, we'll have our holding circuit here. So I'm going to press the start button. And you can see pressing the start button energized my output. And when it energized that output, it drove in this case, it was this, that three-phase motor starter, and closed contacts 13 and 14, which are wired to my input 7 here. And then I got logical continuity because they closed, and now I have a holding circuit, and I no longer needed to hold my start button. And then if we look down here, the motor status pulled in. So as long as this rung has continuity, it is going to be timing. And you can see that it is incrementing the timing value there. Now, if I hit the stop button, you'll notice it did not reset my timer. It retained that time of 53 seconds. So now if I come back and hit start, it's just going to start at 53 and keep incrementing. So that is the difference between a non-retentive timer and a retentive timer. I'm going to go ahead and switch to the jog function. And we get the blue light, so that lets the operator know that if they push start, the motor will not stay running. It will be in the jog function. I'm going to go ahead and hit start here a couple of times, and you can see that my retentive timer is incrementing the time even in the jog function. Okay. So now we'll say that 30,000 seconds is our target for going and doing some preventive maintenance on the motor. So we see that it reached 30,000, and we then will want to reset this counter after we do some preventive maintenance. So all we have to do is push our, what would normally be our yellow button, this lower button here, and I push that. You're going to see the this gain logical continuity, and it will tell that output instruction to reset the timer. Okay, so now you can see my accumulated value on my timer has gone to 0, and if I run again, I will start timing from 0. Okay, so that's how to reset timers. Okay, so we've taken our 2201, just our start stop, and we've extended it to a jog functionality just by using a selector switch, and we have added a run timer in there. We only have to test one more thing, and that is our overload. I'm going to go ahead and go back to run. And our code hasn't changed since 2201, but it's always good to check this. So we have a held motor, and this right here, if I do a test of the overload, should open up or should evaluate to false. It's open right now, and we're examining if open. So if I push on that, it's going to actually close the set of contacts, and when it closes that, this evaluates to a false, which takes away my holding circuit and turns my motor off. Okay, so that is Shop Job 2301. I hope that helps, and we'll see you in the next video.